Engineering and design can be absolutely magic. Finding out that perfect solution is such a satisfying feeling. And today we're going to look at a super cool example from the airplane industry. An example of a solution that I have managed to incorporate in one of my new designs. So did you know this about airplanes? They used to have the fuel tanks inside the body itself, but that was until 1933. Boeing 247D, someone came up with a brilliant idea to move the fuel to the wings instead. So why would you do that? Yes, to put the fuel in the wings, you could actually just get rid of all the fuel tanks. So by getting rid of the fuel tanks, you can reduce weight, improve balance, and also distribute weight across the wings. Here's my airplane. It has a lot of weight in the middle. So when the air is coming under its wings, the wings are folding. It falls down flat to the ground. So what happens if we take these two fuel tanks and move them away from the center of the body and out on the wings? Look at that. By adding the fuel to the wings, we have distributed the weight better, and we have actually decreased the weight on the wings. Look how well it flies. Perfect. The clever design principle that these airplane engineers used is that they took structural parts like these airplane wings and turned them into functional parts. The airplane needs wings anyway, so if they're already there, why not use them for more functionality than only one, right? This is a brilliant design trick that I think that you can use in your own design. So I'm using this trick in my marble machine project. So I tried once building this plywood machine that didn't end up too well. Then I built a second machine, it ended up in the same way, and now I'm trying to become a stronger designer to be able to take on the challenge of Marble Machine 3. So let me show you how I have incorporated this trick. So this is my programming wheel from the Marble Machine X. Let's take a look at the parts here. We start with the center right here. A lot of structural parts, right? And then what do we have more? More structural parts. So all of this is just to create a solid structure. It was really solid and rigid, great, but it doesn't do anything. What do we have then? More structural parts. And only now we add some functional parts. So here's the gears, and then we add some steel plates, and then now at the very end, we add these plastic parts. And those are the functional parts. So around 2 million structural parts and 4 functional parts. What did I do on my new design? Well, let's take a look. So we start with the axle like this. Okay, we have some structural parts, 1 and 2 structural parts, and then that was it. 2 structural parts. Because you know what I did? I made these parts, the slats that I'm making blue here, functional. So these parts are responsible not only for the function of adding the programming pins like this, that's the pins that plays the music, they are also responsible for holding the wheel together. So I made my structural parts into functional parts. That's called fructural parts in the industry. It's not, I'm trying to be funny. And succeeding. Have this implementation made a big difference in the parts list? Oh yes, it have. The original wheel had 142 parts and the new wheel only 38 parts. So that's a pretty good improvement. I used the same trick on this marble gate. So here we have a lot of parts, and some are structural like these profiles, and some are functional like these marble lanes. And on the new gate, I just have one part. So this gray part right here is both the marble lanes and the structural thing holding all the pieces together. I made my structural parts double up as functional parts. The old design had 124 parts and the new design 32 parts. From 124 parts to 32 parts is almost 10 times less parts, but I actually used 2 tricks to achieve this on the marble gate. So here's my 2 principles for good design. Number 1, make your structural parts functional, as we discussed in this video. But number 2 is equally important. Make your design requirements less dumb. If you do this, look how happy you will make Wilson. He's so happy. He loves great design solutions. Efficient, lean, elegant. That's the kind of stuff he's into, you know? Here's another industrial example of the same thing. Electric vehicles used to carry around their batteries like a bag of potatoes, just like extra added weight, and you needed both a frame and batteries. You can say that the frame was the structural parts and the batteries are the functional parts. Could we improve this? Oh yes. Tesla has made this 4680 structural battery pack where they put all the batteries in a honeycomb pattern like this one. And then they pour something that makes it to a solid brick, this pink stuff here. Credit to Monroe Live for tearing this battery pack apart. And that makes a super stiff torsion box. You can see the electric conductors under there. So this structural battery pack combines the structural frame with the functional batteries. By replacing the frame, you reduce weight and you get a stiffer structure, which is absolutely awesome. Look how happy Wilson becomes from stuff like that. My old professor Albus Dumbledore once said, music, a magic far beyond the magic we do here at Hogwarts. And I agree with Albus. When you're into music, time ends and you become immortal. God, I missed that. Anyway, need to get the Marble Machine 3 to work. That's what I'm trying, okay? So music is the highest magic, right? But I would like to say engineering and elegant solutions, when something clicks in your head and from a problem situation with 3-4 things and you just can't get it together, and all of a sudden everything just opens up. Your airplane doesn't only get lighter, it flies better, your car drives better, and your Marble Machine part count is reduced by 10 times, which makes the project potentially feasible. So yeah, after music, I would say that engineering is a close second.